Okay. Most students lose marks on this question because they start with the wrong equation. In redox titration, always start with the titration data because that is the only measured value. Today, we are calculating the percentage impurity. So you can pause the screen first and read the question yourself, and then we'll talk. Okay, so we are calculating the percentage impurity of NH₄VO₃. And to calculate that, I want you to go backward, meaning write the equation of percentage impurity first and then see how we can work out the actual answer. So percentage impurity is equal to the pure mass pure mass divided by impure mass and times that by 100. Impure mass has been given, so I'm just going to highlight that is my impure mass given here. And pure mass you will have to work out. So what should we do for that? This pure mass, to work out the pure mass over here, I'm going to highlight you need number of moles equals m over mr formula, and of so in the mr of NH₄VO₃, and number of moles you can calculate using the titration data given here. Okay, so we can work out the number of moles and then we can just times them to work out the mass. Okay, so the titration data which is provided here in the question, we're going to use that to now find the further part of the question. So I'm just going to rub this arrow out so that you can see it carefully, clearly. And if you see ammonium NH₄VO₃ and trace the path of vanadium, vanadium is going from NH₄VO₃ to VO to 1 plus to V2 plus, and then it is going to VO2 plus. How do I know? It's all given in the question. If you read it carefully, you can see where the vanadium going from where to where, and then what they did with the remaining excess of zinc is removed from biofiltration, and then they use the filtrate which contains the vanadium ion to do the titration. So vanadium ion they are going to use to do the titration. So the vanadium changes form, but the important point is one vanadium NH₄VO₃ contain one vanadium atom, one vanadium atom. That means, what does that mean? So eventually, whatever is the mole of vanadium, whatever is the mole of vanadium 2 plus found by titration, I'm going to write it here clearly so that you can understand. So what does that mean? One vanadium atom in ammonia NH₄VO₃, what does that mean? Moles of V2 plus found by titration, found by titration will be equal to the moles of NH₄VO₃. Why? Because if you see, there is one vanadium atom per molecule. So one molecule contains one vanadium atom. Therefore, whatever is the moles of vanadium will be the moles of the entire NH₄VO₃. Okay, so now let's do the calculation. Start from KMnO₄. Now you start from KMnO₄, and first thing you need to do is to convert the volume. We have been given volume equals 29.43 cm cube. So convert that into dm cube. Okay, and to do that you just have to divide that by 1000, and that gives you the value 0.02943 dm cube of KMnO₄. Okay, and the concentration of KMnO₄ has also been given. So you can see the concentration of KMnO₄ here has been given as this is the volume here, and the concentration has been given. Okay, I can't locate where is the concentration given. Yeah, here we go. This is the concentration here. So you can just use conc, which is given as 0.0200, and then just use it to work out your number of moles of KMnO₄. So I'm just going to use that. So moles will be equals to 0.0200 times 0.02943. I just times the concentration with the volume, and so the answer would be 5.886 into 10 to the power minus 4 moles. Now here is the trick. Please remember, there is a conversion point. Mark for conversion is given on this point, and now you are going to use the mole ratio. Look at this. This is the mole ratio you need to use. So you got the concentration. So the ratio now, I'm going to write it here. Now use equation. Okay, use equation, and it says 3MnO₄ 1 minus plus 5V2 plus gives you 3Mn2 plus 5VO2 1 plus. Okay, therefore the ratio is this. Now this is the important part. Please be careful about this. I'm going to slightly make it bigger so that you can see. So the ratio MnO₄ with 1 minus and V2 plus, write them down clearly, and then do not do the other way around. So that's why I'm writing it clearly. So MnO₄ is 3, V2 plus is the moles of V2 plus is 5. So the ratio is 3 to 5. Therefore, what moles you have got for MnO₄? 5.886 into 10 to the power minus 4 will have X of vanadium ions. So you cross multiply. I normally teach this trick to my students because this works really well. They don't mix up with the 5 divided by, will it be 3 divided by 5 or 5 divided by 3? They always get the right answer. So 3x equals 5 into 5.886 into 10 to the power minus 4, and then you just work out the answer for it, and the value that you will get of X will be equals to 9.81 into 10 to the power minus 4 moles. Okay, so you got the number of moles. Now link back to NH₄VO₃. So remember, the number of moles of vanadium is not changing. It's just going from, look at the board, yeah, carefully. I'm going to show you. Vanadium is going from here. See, look at the board carefully. The vanadium is going from here to here to here to here, right? So I'm going to use that link. So vanadium, from whatever number of moles of vanadium VO2 I have got, that contains one vanadium atom in it. See, there is only one vanadium atom. So that is going to link to your NH₄VO₃ as well. So now you go back to the answer, the calculation again. So therefore, whatever your moles you have got for this is going to be same for NH₄VO₃ as well. So so now I'm going to tell you clearly that even though vanadium ion changes from even though vanadium changes even though VO3 1 minus goes from VO3 1 minus to VO2 1 plus to then V2 plus, the number of vanadium atom, yeah, the number of vanadium atoms stays the same. Okay, therefore the moles is also same as NH₄VO₃. So NH₄VO₃, which contains one atom of vanadium, if the moles of vanadium is whatever is the moles of vanadium atom, will be the mole of the entire molecule as well. Okay, so they have the same moles. Now we can work out the mass. Mass equals moles times the mR. Moles, what we have got is 9.81 into 10 to the power minus 4 times the mR. I got 116.5, and that will give me the answer as equals to 0.011. It will be 0.1147 gram. This is the pure NH₄VO₃, and now you simply divide 0.1147 over 0.151 times it by 100, and that gives you 76% percentage purity of the substance. Now this is my mass I calculated here. Now I hope this makes sense. There were couple of key things in this question that I hope you understood, that we use the titration to work out the moles of vanadium, and the important point is this, that the number of atoms of moles, number of moles of vanadium is equal to the moles of NH₄VO₃ as well, because I think people don't get convinced with that. But I hope this makes sense. Please do let me know if you have any question. Thank you.